Hey everyone, have you ever wished your Java code could just talk to your database? Without all that clunky manual translation work in between? Well, that's exactly what we're going to get into today with Hibernate. Think of it as your code's very own personal database translator. I mean, just picture it. You've spent all this time crafting these perfect Java objects. What if instead of you having to write a ton of code to translate them, you could just hand them off and they'd find their own way into your database tables? That's the dream, right? That's the promise we're going to explore. But, to really appreciate the solution, we've got to feel the pain of the problem first. So let's talk about something I'm sure a lot of you know, the good old database code headache. Seriously, does this look familiar? Writing all those lines of code just to open a connection, run a simple query, handle all the possible exceptions, and then finally close everything down for every single little thing you need to do? It's super frustrating, and that's exactly where our story starts. So this really boils down to the main challenges of doing things the old-fashioned way with JDBC. You've got that mountain of repetitive, what we call boilerplate code. Then there's the fact that your code is basically chained to one specific database, which makes switching a total nightmare. On top of that, you have to manually figure out how your objects relate to each other. And of course, you're constantly dodging a minefield of exceptions that you have to handle for every single operation. It's a lot. Okay, so with that headache fresh in our minds, let's talk about the cure. It's time to meet Hibernate, which is like this amazing, sturdy bridge over all those troubled waters we just talked about. So the magic trick behind Hibernate is a concept called object relational mapping, or just ORM. You can really just think of it as a super smart translator. It's a programming technique that automates that whole tedious job of converting data between your Java objects and your database tables. It handles all the messy details so you don't have to. And this comparison right here shows the difference perfectly. Over on the left, with JDBC, you're down in the trenches. You're writing the raw SQL, you're manually mapping everything piece by piece. But then look at the right side, with Hibernate. Suddenly, you get to work at a much higher level, just focusing on your Java objects. Hibernate does the heavy lifting, it writes the SQL for you, and this is huge, it makes your code portable, so you're not locked into one database. So you might be wondering, how in the world does Hibernate actually pull all this off? It sounds a bit like magic, right? Well, let's pop the hood for a second and see how the engine really works. So here's the typical flow. First, your application loads up a configuration file. From that file, Hibernate builds this one powerful object called a session factory. Then, whenever you need to talk to the database, you use that factory to open a quick, lightweight session. Inside that session, you start a transaction, do all your database work, saving, updating, whatever, and then you commit the transaction to make all your changes permanent. Simple as that. Now that we've seen the basic process, let's get to the really cool stuff. These are the superpowers that make Hibernate an absolute game changer for developers. These features right here are the heart and soul of Hibernate. First, you get database independence. That means you can switch from, say, MySQL to PostgreSQL with almost no code changes. That alone can save a project months of work. Then you have HQL, the Hibernate query language, which lets you think in objects, not tables. It also handles transaction management for you, and it has these amazing caching features to speed things up, which we'll get to in a sec. It's a whole toolkit designed to make your life easier. Okay, now check out this HQL query. This is so cool. Notice what we're not saying. We're not saying select star from the student underscore table. We're saying from student. We're literally talking about the Java student class itself. You get to work directly with your objects and their properties, not some database table with underscores in its name. And behind the scenes, Hibernate just translates this into the right SQL for whatever database you're using. All right, let's talk about speed, because this is where Hibernate gets really clever. By default, it uses something called a first-level cache. The best way to think about this is like a private, temporary workspace just for your current session. If you ask for the same exact object twice in that same session, Hibernate's smart enough to just grab it from the cache the second time, completely skipping a whole trip to the database. It's totally automatic and super efficient. But what about data that lots of different users and sessions need all the time? Well, that's where the second-level cache comes into play. Think of this one like a shared public library for your whole application. You can set it up to store that frequently used data, which means your entire app gets a massive speed boost by cutting down on database hits. It's an incredible performance tool. Okay, so to really bring this all home, let's follow the journey of a single object as it moves through the Hibernate system. Understanding its life cycle from birth to death is really the key to mastering how all this works. So everything kicks off right here in the transient state. When you first create an object in your code, like new student equals, it's transient. It's just floating around in your application's memory. Hibernate has no idea it exists, and it has zero connection to your database. It's brand new. Then the object moves into the persistent state. This happens when you link it to a Hibernate session, maybe by calling a method like session.save. Now the object is officially live. Hibernate is watching it. Any change you make to that object will be automatically noticed and saved to the database as soon as you commit the transaction. That's the magic right there. So what happens after you close that session? Well, the object becomes detached. It's not gone, it still has all its data, but that link, that connection to the database has been cut. Hibernate isn't watching it anymore. So if you make changes now, they won't automatically be saved. You can, however, reattach it to a new session later on if you want. And finally, we have the removed state. This is what happens when you take an object that's being tracked and you tell Hibernate to delete it, maybe with session.delete. The object is now officially marked for deletion, and the moment you commit that transaction, poof, it's gone from the database for good. So as we've seen, Hibernate is this incredible bridge, right? It saves us from all that tedious, error-prone database code and lets us think in terms of our objects. But it does make you wonder, for all its convenience, does adding this complex layer, this powerful bridge, ever slow down the traffic? It's a really important question to ask yourself as you decide when and where it makes the most sense to use it.